Hey everyone, today I'm going to look at a Kubernetes secret workflow because secrets is a little bit of an odd thing in Kubernetes. There is a secret facility, a secret object that you can use, but the workflow differs from company to company, and I find it usually the linchpin of every process, like how do you manage secrets? That's the first question I hear with every kind of workflow. So I'm going to use something that is called sealed secrets. It's from Bitnami, and the reason I'm liking this solution is because, first of all, on their GitHub page there is a very simple problem and solution definition. I can manage all my Kubernetes configs in Git except my secrets. That's my biggest problem. And the solution is, you know what? You can encrypt your secrets into the very same Git repo where you keep your Kubernetes manifest files, and it's going to be secure because it's using an asynchronous cryptographic algorithms, just like an SSH key or an SSL certificate. Basically, sealed secrets is running inside your cluster, which is then able to unseal your encrypted secrets runtime. So during the application is running in your cluster, the secret will be unsealed. And in Git, it's going to be stored encrypted, so it's secure. You can even put it on a public repository. So we are going to build up on a cluster that I have locally. There is not much on it. It was created by K3D. There are a few pods. Basically, there is sealed secrets running in the infrastructure namespace. I have Grafana and Loki just to have something in the cluster, and I'm going to deploy an application, a custom application, and I'm going to demonstrate the secrets workflow. This cluster was created by ONeClick which is one of my tools. It just gives you a very good baseline for every cluster, either if you are in the cloud or even you're working on localhost like with K3D. So I installed Loki and sealed secrets and Linkerd, and in exchange, ONeClick put everything in Git into a Git repository, and this Git repository is then synchronized down to the cluster every 15 seconds. That's the GitOps approach, by the way, and it's achieved by vFlux. It's a component. So there's a bootstrap folder for the automation, and all the components are here. I have this repository cloned, and I want to show you something before I move forward. So how does sealed secrets work? The Linkerd component, which is a service mesh, needs a secret to operate. Basically, the root certificate and the issuer certificate while it encrypts traffic inside the cluster. Long story short, this is how a sealed secrets look inside Git. It's not a secret like with the Kubernetes secret, but it's a sealed secret, and there is an encrypted data field, and I'm going to talk about how to get this encrypted value field into your YAML files. And in runtime, this is actually unsealed. So if I get my secrets inside the cluster, there is the Linkerd certificates, which is or describe secret Linkerd cert. It has the values YAML, which is the unsealed version of that sealed secret. So let's get started. I'd like to deploy an application, and I hate Kubernetes YAML for one reason, because I just don't remember it, how to write it from scratch. For that reason, I actually have something else. It's a simple Helm chart. It's one Helm chart to rule them all. It's a generic chart for web applications or cron jobs. I'm actually going to deploy a simple image just for starters, and I have this one-liner right here. I'm going to write a values YAML file. I'm using Helm, by the way. Basically, this values file tells this chart that, hey, use the nginx image and on this tag. So, and if I just show the generated YAML with Helm, then you will see the long YAML that you might write yourself today by hand. So there's a deployment generated. I have set the image, so it's right here. It's generated into the template, and it also creates a service, because usually you need a service. So that's a very bare bones application, and I could actually pipe this into kubectl apply-f, and then it would be deployed on the cluster. I won't do that right now, because before doing that, I want to add a secret to this deployment. Again, I'm not very good at remembering Kubernetes YAML syntax, so I'm going to look at ONeChart has actually some secret facilities as well, and also there is a section for Bitnami's sealed secrets. So again, just a little piece of YAML. I can define my sealed secrets in this format, and sealed secrets is the key, and this is my first secret. I just call it secret 1, and I have to put something encrypted here, which here comes the sealed secrets part, like how to take your secret values and how to encrypt that into something that is securely stored in Git. The sealed secret workflow is described on their GitHub page. Basically, there is a command line utility called kubeseal, which is able to fetch the sealing or signing key, and I'm going to encrypt this piece of secret I have. One-click info, by the way, has a nice one-pager for every component, and with sealed secrets as well. It tells you how to install kubeseal, and after the installation, how to obtain the sealing key, like how what you can use to encrypt stuff. So I just get it from the cluster. So that was a kubectl call in the background, or a Kubernetes API call. And here is my sealing key. This is a public key again, so you can put this on your website. You can put this anywhere. You can even put into your team's source code repositories, because this is the public key. You can seal the keys with this one, or the secrets with this one, but you cannot unseal. So only the private key inside your cluster is able to decrypt the secret. So I have the sealing key, and going back to ONeChart, it has actually just a simple one-liner how to seal a secret value. My secret value is my secret value, and it takes from standard in. I have to seal the namespace into the secret, because sealed secrets encrypts the name of the namespace and the name of the secret as well inside the value. So this just gives you some additional security. So if people have access to multiple namespaces, they won't be able to copy secrets from one place to the other. So the namespace was infrastructure. I'm going to use, or I'm going to name my secret like this, and I have to feed in the certificate, which was just fetched from the cluster. And if I do this, then this is the sealed value from my very special secret. And if I put this right back to the Helm charts values file and template again, you can see that a sealed secret was generated with the encrypted data in the right namespace and with the right name, and also this secret is referenced from the deployment. So if I apply this on the cluster, then we will be able to see the secret. But before doing that, I'd like to print this secret out. So I'm going back to ONeChart again, because I want to run a custom command inside the container, and I'm actually taking this whole thing because I need just a Debian image, and I'm going to print out secret 1 every 2 seconds. So again, this is a slimmed down version of the Kubernetes YAML file, and I actually like it because it makes me more productive. Just templating it one more time to show you that the comment has been overwritten. And if I apply now this on the cluster, kubectl apply -f, and take it from the input, things were created. So first of all, there is a my release pod. There is also a secret called my release, which has or should have the secret value. And it's almost ready. Just 1/2. I'm looking for 2/2 here. Yes, it's 2/2, and if I'm logging out my release, what's going on inside in the my release container, you can see my secret value has been printed out multiple times by now. So actually what has happened is that we have created a sealed secret inside a cluster called my release, which in turn was unsealed, and the secret was created, and then the secret was referenced from the deployment. So we have all the components to have this secret workflow up and running. And there's one final thing I'd like to do is I'd like to version this Kubernetes YAML file, because it's very nice that I could just template it and apply it immediately. It's not very future-proof. In order to do that, I'm actually going to use the automation that one-click infra has, because all these system components are applied every 15 seconds. I told you this before, and I'm actually going to extend this repository. So I'm just piggybacking on this automation. I created an apps folder in which I'm going to store my application configuration. But before doing that, I am just extending Flux. That's the component that syncs everything from this repo to the cluster. So I am now applying a third folder called apps, and I'm going to steal one of the Helm releases. That's a special Kubernetes YAML piece. It's made possible by the Helm operator, which is basically a Helm install, upgrade, and template combined. I like it very much because it has a very nice declarative syntax. You can reference a Helm chart, and then you can provide values to it. So just like my values file, I can just put my values file in it. So it's called myrelease.yaml. The name will be my release. Namespace infrastructure. Release name is my release. Repository, I think it's chart.onechart.dev, and the name is ONeChart. Cool. Version. Let me just Helm show chart ONeChart /ONeChart 070. So I'm referencing this exact version, and I'm just stealing my values from this this file, which is not needed anymore. So these are my values, just identing them properly, and I'm crossing fingers because this should fly, but I might make some mistakes. So this is the Helm definition. Take the chart, apply the values, and since this secret is encoded, I am very comfortable putting this in a Git repo. It's actually a public Git repo right now, and this repo will be kept for future references. So what's in here? I'm going to add apps because that's where things are. I'm going to add the change in the bootstrap folder because I changed what folders we need to apply. And you know what? I could add the sealing key as well because it has no security risk in it, but I'm just gonna keep that for now. So committing, testing sealed secrets with ONeChart chart, and I'm going to push this to master. I really should go to main origin. And I'm crossing fingers now because what will happen is that things go to GitHub, and then the automation will sync it back to the cluster. So, and to see that, I should see a Helm release CRB. Just making it one smaller. I actually don't see it yet. Oh, there we go. So it was 0 seconds ago, a chart fetched, and it was failed. I'm guessing it's because the things it would like to create already exist. So let me just get the reason. why this Helm release failed. Existing resource conflict, yes. So that was a mistake in the preparation of this video, but I can just delete deployment my release. Yes, delete secret my release, delete sealed secret my release, and delete service my release. And since to retry this Helm release, I think I'm going to delete that as well. Yes. And to force Flux to recreate stuff, I think I'm just going to delete the pod, the Flux pod, because yeah, kubectl delete pod in the Flux namespace called Flux, because when Flux starts up, it will reapply the latest commit. So I'm really hoping that this Helm release comes back and things will be just created. It's being installed, it succeeded, getting the pods right here, getting the secret, it's right there. And if I'm doing the logs on my release, on the right container, I'm seeing the values. So that's that. And just to recap what I've done here, I wanted to show you a secret workflow that is simple, because secret workflows in companies are left and right. They try to comply with security standards of the company, and also like the organization charts. So sometimes the operations people set secrets, sometimes developers, but the split is really messed up because developers will want to set secrets at some point, and I would even say that like 30 or 50% of secrets are set by developers. But of course there is the keys for the castle set by ops. I understand all that, but if you're lucky enough to be in a company where developers could see these secrets, this sealed secrets workflow is actually very nice, because it's not a split workflow. It's not that you keep secrets somewhere here, you keep your YAMLs application deployment somewhere there, and then it will magically come together at some point by some process. It's the same process deploying your applications, your secrets and everything, and is made possible by sealed secrets and the encrypted secret approach. There are other solutions as well, like Mozilla SOPS. I think that's also another way to encrypt your secrets. And if you encrypt your secrets in Git, then you can have a very nice GitOps approach, because everything now in a Git repository. And if it's a Git repository, I very much like this Helm release approach, because the Helm chart, revision, and the Helm values are in one place. I am liking my own thing, ONeChart. Of course I like it, because it just makes me faster. The common use cases with ONeChart are listed here, and it's going to be extended in the future, because I'm using this, so every time something comes up, I will just add the case here with the unit test. It's open source, it's on GitHub, 0/0 fork, so please go and like it. And what else? And yes, I've built on top of one-click infra setup on K3D locally, but you can do this on DigitalOcean, Linode, Azure, AWS, whatnot. And actually go and check out one-click infra as well, because there are multiple components here, and the list of components are constantly being extended. And I'm just hoping that I'm doing a service for you, because I believe getting a good operational cluster equipped with the right Kubernetes stuff is very easy with one-click infra. Also, ONeChart is super nice. You can fork it for your own company if you wish to do that. And yeah, that's that. I'm very pleased with the result. Also, the components we used, and actually how ONeChart turned out very nice in this demo. So thank you very much for your attention, and have a good day.